Hello students. In the last class we have discussed the chapter quadrilateral up to theorem 8.2. Today we will discuss theorem 8.3. So in this 8.3, so theorem is if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. That is, we have a quadrilateral and given that the opposite sides are equal. Now we have to show that this quadrilateral is a parallelogram. That means in a parallelogram opposite sides are equal. So since we have to show that it is a parallelogram, we have to draw a parallelogram. So here opposite sides of a quadrilateral, so we can't draw any quadrilateral here. So opposite side must be equal. So we will draw a parallelogram here. First we draw a parallelogram. Name it A, B, C and D. And in this quadrilateral, it's a quadrilateral, four-sided closed figure. So AB and CD are equal. That is opposite side. That is AB and CD are equal, and this AD and BC are also equal. Now we have to prove that it's a parallelogram. Parallelogram means the opposite sides are parallel also. So in a special statement part, we have to write, since given opposite sides of a quadrilateral, so first we have to mention this ABCD as a quadrilateral. So let ABCD be a quadrilateral in which the opposite sides are equal, that is in which AB is equal to CD, or you can write DC also, and AD is equal to BC. That is AB is equal to CD and AD is equal to BC. So to prove, what I have to prove? ABCD is a parallelogram. That means AB is parallel to CD and AD is parallel to BC. So we have to construct a diagonal here to prove. That is, we have to draw a diagonal. So we have to write it in the construction part. So construction. So to make the proof easier, we join or draw the diagonal AC. We join AC. Now how we prove it? So we get here two triangles ABC and CDA, and in these two triangles, see, AB of sides ABC is equal to CD of this triangle CDA. Next BC is equal to AD, and AC is the common side. That means all the three sides are equal to all the corresponding three sides of this triangle CDA. That means by side, both the triangles are congruent, and if they are congruent, then the angle here ACD is equal to BAC by the CPCT. That means if these two are equal but they are alternate interior angles made by the transversal AC with AB and CD, that means AB and CD are parallel. That is, if the interior angles are equal, then the lines are parallel. Similarly, we get this angle and these angles are equal. That is, they are also alternate interior angle and equal. That means AD and BC are parallel. That is, opposite sides are parallel. That is a parallelogram. So we will prove it here. So in proof part, right, in triangle ABC and CDA, not ADC. Triangle CDA, we have AB of this triangle ABC is equal to CD of this triangle CDA. Why they are equal? Because the given or opposite sides of this quadrilateral. Next we write BC is equal to DA. BC and DA are equal, so they are also given, and AC is equal to CA. They are common side. Next, common side. Therefore, triangle ABC is congruent with triangle CDA by S congruence rule. Next, so this is congruent. Therefore, angle BAC is equal to angle DCA and angle BCA is equal to angle DAC. Yes. Why? Simplicity. But angle BAC and angle DCA, that is these two, BAC and DCA, these two, this angle and this angle, are the alternate interior angles made by the transversal AC with AB and CD. Therefore, AB is parallel to CD because they are equal and they are two alternate interior angles. So you get this. Next, similarly, double LY means similarly, these two angles, angle BCA and angle DAC, are the alternate interior angles. That is this angle and this angle, these two angles. BC and DAC are the alternate interior angles made by the transversal AC with BC and AD or DA. Therefore, BC is parallel to AD. That means both the opposite sides, both the pair of opposite sides are parallel. That is, in quadrilateral ABCD, both pair of opposite sides are parallel. Therefore, ABCD is a parallelogram. This is the proof. So next theorem is theorem number 8.4, and here it's given that in a parallelogram opposite angles are equal. That is, if we have a parallelogram ABCD, then the opposite angles are equal. That is, angle A and angle C are equal, and angle B and angle D are also equal. We have to prove it. So, at special statement, so in a parallelogram, that means we have to write let ABCD be a parallelogram. So to prove, what do we have to prove? We have to prove that angle A is equal to angle C, angle A and angle C are equal, and angle B is equal to angle D. That is, this angle B is equal to angle D. And to prove it, first we have to make two triangles. That is, we have to draw a diagonal, either AC or BD. So we draw here AC. So when we draw, we get two triangles ABC and CDA, and we know that they are congruent, but here we have to prove it. If they are congruent, then corresponding angles are equal. That is, angle B and angle D are equal. We will get here. And if you draw the diagonal BD, then we get the triangle ABD and BCD. Then C and D are equal. So we will prove it. So write construction part. To make the proof easier, we draw the diagonal AC, or simply write we join AC. Same thing. In the previous sum we write only we join AC, and here we write we draw the diagonal AC. So now proof. So in triangle ABC and triangle CDA we have. So in this two triangle, you can use the opposite sides are equal or angle equal. You may use any properties of. So, but here we will write that this angle and this angle are equal. Since it is a parallelogram given, angle BAC is equal to angle DCA, alternate interior angles. Since AB and CD are parallel and AC is transversal, and this angle BCA is equal to angle DAC, same alternate interior angles, and AC equal to CA, common. AC equal to CA. Therefore, by angle side angle criteria or congruence rule, triangle ABC is congruent with triangle CDA. That means here angle B is equal to angle D. Therefore, angle ABC is equal to angle CDA. That is angle ABC, that is angle B. CDA means angle D. That is angle B is equal to angle D. We get here angle B is equal to angle D. Now I have to show that angle A and angle C are also equal. So right we have here, this is given now, BAC and DC are equal, angle BAC equal to angle DCA. This only, BAC and DCA, suppose number 1, and here BCA and DAC are equal, but we will write, since here angle A, BAC is here, and angle DAC, that is both are related to angle A, so we will write this BC and DAC simply angle DAC is equal to angle BCA. This is the, we will write only the reverse way, such that we can add them. This is number 2. Now 1 plus 2 implies here angle BAC plus angle DAC is equal to angle DCA plus angle BCA. That is left hand side plus left hand side is equal to right hand side plus right hand side. BAC means BAC, that is this angle, plus DAC that is this angle. So if we add this, we get angle A, and DCA that is this part, plus BCA plus this part, so we get the total angle C. That is, here we get angle B is equal to angle D, here we get angle A equal to angle C. Hence, so this is the proof of this theorem. So our next theorem is theorem 8.5. This is the converse of the previous theorem. In the previous theorem, if it is a parallelogram, then opposite angles are equal. And here, we take a quadrilateral in which each pair of opposite angles are equal. That is given here, opposite angles are equal. Now we have to show that it is a parallelogram. That means the opposite sides of this quadrilateral are parallel. So we take it A, B, C, D. So is a quadrilateral first, in which angle A and angle C are given equal, and angle B and angle D, that is opposite angles, are equal. Now I have to show that AB is parallel to CD and AD is parallel to BC. So in special statement, what we have to write? In a quadrilateral, that means let ABCD be a quadrilateral in which opposite angles are equal, in which angle A is equal to angle C and angle B is equal to angle D. To prove ABCD is a parallelogram. We have to prove that. Next, in the proof section, we will use the angle sum property of a quadrilateral. That is, angle A plus angle B plus angle C plus angle D is equal to 360 degree. This is the angle sum property of a quadrilateral, and we will use the theorem related with parallel lines. So in the parallel lines, just we mentioned here, if there are two parallel lines and both the lines are intersected by a transversal, then the angles on the same side of the transversal are supplementary. That is, interior angles on the same side of the transversal is supplementary. That is, if we add these two angles or these two angles, then it equal to 180 degree if they are parallel. And there is a converse theorem also. If any two lines are intersected by a transversal, and if somehow the sum of these two interior angles on the same side of the transversal is 180 degree, that is, if we add them and we get 180, then these two lines are parallel. So we will use this theorem here or this property here. So write proof by angle sum property of a quadrilateral, we have angle A plus angle B plus angle C plus angle D is equal to 360 degree. Angle A plus angle B plus angle C plus angle D. Now this implies angle A plus angle B plus, in place of angle C, because angle C is equal to angle A is given, so we can write angle A plus, in place of angle D, in place of angle D we can write angle B here. So angle B is equal to 360 degree. That is angle A plus angle B plus angle A plus angle B. That is twice of angle A plus angle B. That 2 angle A and 2 angle B, that is twice of angle A plus angle B is equal to 360 degree. That means angle A plus angle B is equal to 360 degree by 2, that is 180 degree. That means you get this angle, angle A plus angle B are 180 degree. But angle A and angle B are, let's see, these two lines AD and BC, and there is a transversal, that is intersect both the lines. Then these are two interior angles on the same side of the transversal. So, but angle A and angle B are the interior angles on the same side of the transversal AB with the line AD and BC. So we write some shortcut INT, that is interior, this angle sign SN angles. So but angle A and angle B are the interior angles on the same side of the transversal AB, that is AB is the transversal with the line AD and BC. Therefore, that is, but A and A plus B equal to 180, they are supplementary and they are the interior angles on the same side of the transversal. Therefore, AD is parallel to BC because AD and BC are parallel, since they are supplementary. Right. Again, we have, so angle A plus angle B is equal to 180 degree. We know it. This implies angle A plus, in place of angle B you can write angle D because B and D are equal. So angle D is equal to 180 degree. That is angle A and angle D. If we add these two angles, then also they are supplementary. That is 180 degree. Angle A and, right, since angle A and angle D are the interior angles on the same side of the transversal. Here, which is the transversal? AD is the transversal. Transversal AD with AB and DC. AB and DC. Therefore, AB is parallel to DC. That is, we get AD is parallel to BC and AB is parallel to DC. That is, both the opposite pair of sides of quadrilateral ABCD are parallel. That is, both the opposite pair of sides of quadrilateral ABCD are parallel. Therefore, ABCD is a parallelogram. So, this is the proof. Okay? Very easy proof. Practice it. Okay? Thank you.